Hello everyone. Welcome to my channel Chemistry by ANR. In this part of the module, we are going to discuss about naming of coordination compounds as per IUPAC norms. First thing is formulas of mononuclear coordination entity. Mononuclear entity means it contains single metal atom. Mononuclear coordination entity contains central atom as a single entity. That means single central metal atom. When you are writing the formula, there are certain norms to maintain. First thing is the central atom is to be listed first. Inside the coordination sphere, in the square bracket, first you write the central metal atom, followed by the ligands in alphabetical order. Now, the placement of the ligand in the list does not depend on its charge. It's not that the positive, negative ligands, they are placed in this manner. The neutral ligands are placed. Always remember, first the central atom is to be written inside the formula, followed by the ligands in alphabetical order. Now, polydentate ligands are also listed alphabetically. If they are abbreviated ligands like ethylene diamine or ethane 1,2 diamine, abbreviated ligands, they are written as EN. EN is for ethane 1,2 diamine. OX is for oxalato. All these things, the first letter of abbreviation is used. First letter of abbreviation is used to determine the position in alphabetical order. Next, the formula for the entire coordination entity, whether it has a charge or it does not, should always be in square bracket. The coordination entity should be in the square bracket. If the ligands are polyatomic, then for polyatomic ligands, parenthesis should be used. That is, it should be written in first bracket. Now, if they are abbreviated ligands, then the abbreviations should be used in parenthesis. There should be no space between the ligand and the metal within the coordination sphere. When the formula of a charged entity is written without when you are writing it without that of the counter ion, you need to actually be careful what charge you are giving over it. The coordination entity may be positive or may be negative, but if it is positive, that needs to be written first. And if not, then the positive part of the complex is always to be written first, followed by the negative part. Now, naming of mononuclear coordination compounds here, let us see that how to name. Previously, we have seen how to write the formula. Now, how to name them. So, if we know which is the positive part, then we have to name the positive part first. The cation is named first in both positively and negatively charged coordination entity. If you have a coordination entity which is positive part, then also the cation is to be named first. That is, the coordination entity is to be named first. And if the coordination entity is your negative part, then the counter positive ion is to be named first. The ligands are to be named in alphabetical order. Now, before the name of the central atom or ion, when you are writing the formula, you are first writing inside the square bracket the metal atom. But when you are naming it, you are not writing the metal first. You are writing the ligands in alphabetical order, followed by the metal. Now, when you are writing the ligands in alphabetical order, remember for anionic ligands, you add O. Like oxalato, like chlorido, you are giving O. For neutral ligands and cationic ligands, the name remains, not anything extra is added, but a different name is used. Like aqua for H2O. These are the exceptions. Other than this, the name remains the same. H2O, aqua. Please don't write aquo, make it aqua. amine for NH3, remember there is a double M. Carbonyl for CO, nitrosyl for NO, they are all neutral ligands. While writing the formula of the coordination entity, these are enclosed in brackets because they are having more than one type of atom. Cl will not be given in bracket, but if you are writing H2O, it has H and O, then obviously it needs to be written in bracket. If you are writing I, you are writing Br, they won't be having brackets. Now, prefixes like mono, di, tri is to be used based on how many ligands are there. Now, you use bis, tris, tetrakase for ligands which are actually chelating ligands. That means the donor sites may be 2 or more than 2. Like this one, we can see it is named as dichlorido. Alphabetically, C comes first and C is written first also in the square bracket. Bis, triphenyl phosphine, nickel 2. One more thing you need to remember, that how to name the metal. If the metal belongs to a positive coordination entity, or maybe it is not having any charge in the coordination entity, then the metal will be named in its original form. But if it is a part of the negative, I will say coordination entity is negative, then the metal will be followed by 8. Had nickel been a part of the negative coordination entity, then it would have been named as nickelate. Cobalt will be named as cobaltate, but iron will be named as ferrate. Silver will be named as argentate, so on. Now, if the complex ion is a cation, metal is named the same as the element. Now, for example, cobalt remains cobalt only. But if it is an ion, then cobalt becomes cobaltate. Remember, 8 is to be added. Next, we have, say, examples are being given over here. This is one example which is being given. So please do not see the solution when you are trying to write it down. So first you have to name the ligand. Ligands are amine, A, and aqua, that is also A. But after A comes M and here comes Q. So this amine needs to be given first. How many are there? 3. So triamine, triaqua, then write chromium. Don't write within bracket 3 at first. Just give the bracket and move on to write the counter ion, which is chloride. Now you have to see what is to be placed inside the bracket at last. What is the oxidation state? If you remove the counter ion Cl, the charge over the coordination entity is +3. So CrNH3 whole thrice, H2O whole thrice, the charge is 3 plus. So if Cr is taken as X, H2O and NH3, they are neutral ligands. What is the oxidation number? It is +3. So you have got this. Moving on to the next one. CO, NH2, CH2, CH2, NH2, whole thrice, whole twice, SO4, whole thrice. You may think that it's so complicated, but it is not. Mark that this is your coordination sphere, which is written at first. So it is the positive part. Negative part counter ion is sulfate. So when you start naming the coordination entities, start with the ligand. There is only one type of ligand, which is ethane 1,2 diamine. How many are there? 3 are there. But it has 2 donor sites. It is a didentate ligand. So for 3 you will write tris. So it is tris, ethane 1,2 diamine, cobalt. Leave space for this and write sulfate. Now to write the oxidation state, similarly what you need to do is, it is actually CO, En whole thrice, and here it is 3 plus. and of course SO4 2 minus. If anyone asks you that what is the primary valence, that is obviously it is the sulfate ion, how many you are getting. So here it is En is a neutral ligand, and so cobalt has oxidation state +3. Next, moving on to this type, which is a different type, and it is what? Like there are two types of coordination entities. Obviously, the first part is the positive one, the second part is the negative one. So, silver will be given for the first and argentate will be given for the second. So, when you name it, it is 2-amine. So, diamine silver. Give the bracket, don't write what is the oxidation number or oxidation state, and then go to the next one where you see 2 CN are there. So it is dicyanide. Because cyanide it is, just in place of E give O. So dicyanide. Argentate, because this is the second part, which is the negative part. Now, here it is neutral, so charge is 0, but here it is -1, so total whole twice -2. So silver will actually have over here +2 charge, which is distributed as silver 1 and argentate 1. The overall charge is distributed in the two coordination entities. Next, write the formulas of these. Though it is solved, I'm not showing you the solution, I'm just telling you how to do it. Tetramine, so you can see that here the coordination entity is named first. So you can see over here that it is tetramine. But what, first you have to write the metal. Where is the metal? Here is the metal, cobalt. So write CO. Now, tetra means 4, amine means NH3. So, NH3 whole 4. Aqua, for that you can write H2O. Then chlorido. I will not use the bracket, I will just write Cl. Now I'll close this, and counter ion is chloride. And it is already given cobalt is 3. If cobalt is +3 and these are neutral, NH3 and H2O, and Cl is -1, leftover charge is 2. So obviously it is 2 plus, so Cl2, because Cl has a valency of 1, it is -1. So this is how you will write. Next one, you can see potassium. So the coordination entity is the negative part. So write K first, and then you write what is the metal. Zinc is the metal. Tetra means 4. Hydroxido means hydroxide se aaya hai. So you can say hydroxido means OH whole 4. And now you have written it in this manner, and they have given zincate 2. Zincate 2 means it is the negative part and it has +2. If zinc is +2 and here OH is whole 4, so -4 it remains as -2. So it will be K2. Okay, because it will be K plus, and the charge over here will be 2 minus, crisscross of valency, and you get to write this. Next one, potassium, so K, and then you can write aluminium over here. Trioxalato, try to write tris. Trisoxalato means 3 oxalate ion are there. So OX I can write, or C2O4. So like this 3 are there. Aluminate means this is the negative part and this is +3. So let us see, if this is 3, oxalate each is -2 into 3 means -6. Leftover is -3. So it will be K3. Crisscross of valency, potassium is 1. Like this, you have to do the rest. So write the IUPAC name of this. So when you are writing the IUPAC name, you have only the coordination entity being given. Ligand in alphabetical order. Amine, chlorido, nitrito, N, because it is written NO2. Had it been ONO, then it would have been nitrito O. So 2 amine are there, so diamine. Chlorido, nitrito N. Now, platinum, because it's not the negative part, so platinum. Now you give the bracket and see what will be the oxidation state. Then it will be NH3 is neutral, Cl is -1 and NO2 is -1 and overall charge is not there. So obviously this needs to be +2. So the other one, positive part is potassium. So first you write potassium. Now this is a didentate ligand and it's 3. So I will write tris. So write tris. Tris C2O4 2 minus is oxalato. Oxalato, and this is the negative part, so we are writing chromate. Now for the oxidation state, you give the bracket and then check out. So if you remove this counter ion, what coordination entity you will get is Cr C2O4 whole thrice 3 minus. So if chromium I take as X, then -6 is equal to -3 or X is equal to +3. So it is chromate 3. Likewise, you can do the other two also. So here we can see positive part. So amine is 5 over here, and then the D part I'm talking about, and CO3 is carbonato. So pentaamine. So double A will remain, double M will also remain. So pentaamine carbonato and cobalt chloride. Give the bracket and then check out. Check out means here again the charge will be +1 and this is -2. So you get +3. X minus 2 is equal to +1. So X is equal to +3, like this. So here again you can see this is mercury. It's not always necessary to write mercury 1. You can write mercury and then you can write tetrathio. Why thio? Because it is sulfur is the donor side, so SCN is written. So tetra for 4, thiocyaneto S. So S is the donor side. Cobaltate, this is the negative part. Now cobaltate 3. Now nothing is written over here means the charge over here was 1. So SCN is minus. Like that 4 are there. So if I can write X minus 4 is equal to 1. So X is equal to, okay, over here X will be equal to 3. So this is what we can say, that this is the negative part. Okay, so instead of 1 it is -1. So if it is -1, then X will be equal to -1 plus 4 and hence it is 3, because here this mercury is your positive part and this is your negative part. So let us see this once more. Mercury is the positive part, so you write mercury, then write the ligand. 4 ligands, I mean SCN whole 4 is there for that tetra. And what is SCN? SCN is thiocyaneto S. So thiocyaneto S. Cobalt, I am not writing. I have to write cobaltate because it is in the negative part. Now SCN is anionic ligand with a charge minus. We will write minus. Now if cobalt is X, for 4 SCN we can write 4 is equal to -1. Why -1? Because this is the anionic part. That is it. And here again we can see this one. This one is what? This is the coordination entity, is the positive part with 2 chlorido. So what can we say? We can say dichlorido, and then we can say bis, because this is didentate ligand. So bis. Now bis ethane 1,2 diamine. Ethane 1,2 diamine. Here a single M. Now again cobalt. And then we are not writing what is the oxidation state. We are writing the counter ion, which is chloride. So let us see this. What is the oxidation state? How to see that? CO, Cl2, En whole twice. Charge is +1. And so if this is X, I can say X minus 2 for chloride or chlorido, En is neutral, is equal to +1 or X is equal to +3. So here it will be 3. So that is what we have seen. It is what? It is dichlorido base ethane 1, 2 diamine cobalt 3 chloride. That is it. Now here again there are in text question. You need to write the formulas. Tetramine. So see cobalt. That means what? You have to start with the square bracket. Write cobalt. Tetramine means NH3 will be 4. So you write NH3 4. Diaqua means H2O will be 2. So you write 2. And then you write chloride. And it's already mentioned cobalt is 3. So if cobalt is 3, NH3H2O is neutral, then overall charge might have been 3 plus, and so we can write Cl3. What we can write is Cl3 in this manner. Next, potassium. So we can write K. Then we are opening the square bracket. It's nickelate. So I'm writing Ni first. Tetracyanido. So Cn whole 4. And then I close the bracket. And nickelate 2. So this is +2. Nickel is +2. And Cn for 4 it will be -4. Remaining is -2. So here it is K2. Like this we need to solve it. Like let us say this one again. Tris ethane 1, 2 diamine chromium 3 chloride. So obviously I'll begin writing with Cr. And tris means 3, so En whole thrice, or I can write NH2, CH2, CH2, NH2 whole thrice. Now I'll close the bracket and I'll write Cl. Now chromium 3, so obviously it is Cl3 over here. Like this you can solve the others and write the IUPAC name. I think we can try it. It's like in random manner. Like this one will be what? This is potassium. So this will be potassium. And then we can start naming like tris oxalato. Tris oxalato, and then this is the negative part, so I can say ferret. Now ferret, how much? That if this is K3, then obviously the coordination entity might have been 3 minus. So if I say X minus 6 is equal to -3, so this is obviously +3. Now what will be this again? This will be potassium. This is potassium, and then is your tetrachlorido, and negative part it is, so I can say palladate. And palladate, how much? This is 2, so obviously this has been 2 minus, so I can say X minus 4 is equal to -2, so palladate 2. Next, this one, people face difficulty, but nothing to worry. It is what? This is the positive part. This is diamine. So double M, diamine. Cl is chlorido. And then NH2CH3 means methanamine. So it is methanamine. And we can see platinum, and then we'll write chloride. So it is platinum, and then we are writing the oxidation state later on, and we are writing chloride. So what it will be? So this is -1 and X. This is X, and these are neutral. So we can write that X is equal to +1. Here X minus 1 is equal to, nothing written over here means 1, so +1, and X is equal to +2. So this is platinum 2 chloride. So let's get it. Platinum 2 chloride. So this is how we are going to name, we are going to write the formula, and it's not that difficult once you understand the concept properly. So see you in the next module. Till then, bye all of you.